Hello and welcome to our channel. Today we will be doing a deep dive into deep learning and all its components. Part 1. What is deep learning? Deep learning is a subfield of machine learning concerned with algorithms inspired by the structure and function of the brain called artificial neural networks. Deep learning is a machine learning technique that teaches computers to do what comes naturally to humans, such as learn by example. Deep learning is a key technology behind driverless cars, enabling them to recognize a stop sign, or to distinguish a pedestrian from a lamppost. It is the key to voice control in consumer devices like phones, tablets, TVs, and hands-free speakers. Deep learning is getting lots of attention lately, and for good reason. It is achieving results that were not possible before. In deep learning, a computer model learns to perform classification tasks directly from images, text, or sound. Deep learning models can achieve state-of-the-art accuracy, sometimes exceeding human-level performance. Models are trained by using a large set of labeled data and neural network architectures that contain many layers. Why does deep learning allow such impressive result? Accuracy. 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 Deep learning achieves recognition accuracy at higher levels than ever before. This helps consumer electronics meet user expectations, and it is crucial for safety-critical applications like driverless cars. Recent advances in deep learning have improved to the point where deep learning outperforms humans in some tasks like classifying objects in images. While deep learning was first theorized in the 1980s, there are two main reasons it has only recently become useful. Firstly, deep learning requires large amounts of labeled data. For example, driverless car development requires millions of images and thousands of hours of video. Secondly, deep learning requires substantial computing power. High-performance GPUs have a parallel architecture that is efficient for deep learning. When combined with clusters or cloud computing, this enables development teams to reduce training time for a deep learning network from weeks to hours or less. How deep learning works. Most deep learning methods use neural network architectures, which is why deep learning models are often referred to as deep neural networks. The term deep usually refers to the number of hidden layers in the neural network. Traditional neural networks only contain 2 to 3 hidden layers, while deep networks can have as many as 150. Deep learning models are trained by using large sets of labeled data and neural network architectures that learn features directly from the data without the need for manual feature extraction. One of the most popular types of deep neural networks is known as convolutional neural networks, CNN or ConvNet. A CNN convolves learned features with input data, and uses 2D convolutional layers, making this architecture well suited to processing 2D data, such as images. CNNs eliminate the need for manual feature extraction, so you do not need to identify features used to classify images. The CNN works by extracting features directly from images. The relevant features are not pre-trained, they are learned while the network trains on a collection of images. This automated feature extraction makes deep learning models highly accurate for computer vision tasks such as object classification. In Part 2, we will be looking at the difference between deep learning and machine learning, as well as the multiple applications of deep learning and how to create and develop different learning models. We hope that you enjoyed the video. Please hit that like and subscribe button so not to miss out on more.